Last lesson, we picked our fix, a second triage sweep at 1 p.m. Cheap, fast, low risk, and it won on the numbers. But I ended by asking a question, and it's the question that separates an improvement that lasts from one that quietly dies. How will this fix fail? Ours has an obvious answer. It depends on a person remembering to do it, and that is exactly Poka-yoke's territory. Designing the work so the mistake is hard or impossible in the first place. Not training harder. Not trying harder. Designing better. Same route as always. From the assignment, go-to, toolkit, and filter to improve. Poka-yoke sits right next to the tools we've already used. Classify an error as prevent, warn, or detect. The term comes from the factory floor, and it translates roughly as mistake-proofing. A jig that only fits the part one way round, a connector you physically cannot plug in backwards. The idea travels into an office perfectly well. A form that won't submit without a required field is Poka-yoke. So is a rota with a named backup. No runs on this project yet, so we start one. A title, the two report toggles again, and then the section that does the real work. Mistake-proofing. First, name the error. Not the cause, not the blame, the failure itself. Skipped step. The sweep doesn't happen. Then the mechanism. And this drop-down is a hierarchy, not a menu. Read it from the bottom up. Detection, catch downstream. The mistake happens, and you find it afterwards. That's the weakest form. You're still paying for the error. You're just paying a bit less. Warning. Alert the operator. The mistake is about to happen and something tells you, better. But a warning can be ignored. And on a busy afternoon it will be. Prevention, Gishi block the error. The mistake can't happen at all. That's the one to reach for. And it's the one we're choosing. Now describe the error honestly. The 1 p.m. sweep depends on a person remembering it. On a busy afternoon, or when the owner is on leave, it quietly doesn't happen, and nobody finds out until the next morning's queue is already full. Notice that one word. Quietly. That's the dangerous part. A fix that fails loudly gets repaired. A fix that fails silently just stops working. And everybody carries on believing it's in place. So the intended outcome has to spell out what can't fail actually means. The sweep cannot be silently skipped. If tickets are still unassigned at 1:30, they route themselves, and the team lead is told it happened. And then, how? Auto-assign anything still unassigned at 1:30, round robin, to agents on shift. The human sweep stays the fast path. The timer is the floor underneath it. The rota names an owner and a backup for every shift. Look at what just happened there. Auto-assign was the candidate that lost last lesson. Third place. 182 points. It lost as the main fix because as the main fix it was slow and expensive to build. As a safety net that only fires when the cheap fix gets missed, it's a far smaller piece of work. And it makes the cheap fix impossible to skip. Last thing, rename the run so it says what it protects. Midday sweep. Make it hard to skip. So we have a fix, and now we have a fix that can't quietly stop working. What we don't have is any evidence that it does anything. Everything so far is a plan on a screen. Next lesson, we run it for real on a slice of the queue. A proper pilot with a rollback rule written down before we start. And then we test the before and after with a paired T. Not the two-sample T we used back in Analyze. A paired one. And I'll show you exactly why that difference matters. See you there.